Right. Okay, so today's webinar is on the life cycle assessment tool, the LCA Quick, which is a technique of calculating the potential environmental impact of a building's material, energy and water consumption over its full life cycle. I'm very pleased to welcome Brian Berg and Dave Dowell in the room today, or in our virtual room over in Wellington, rather. Brian is a building environmental scientist, and Dave is the principal scientist in sustainability at Brands. Brian did a presentation for us last November, actually, in one of our Green Room events on New Zealand's first Green Star Whole Building Life Cycle Assessment Innovation Challenge. For those of you who are familiar with our tools, you'll know what I'm talking about. But today, Dave and Brian will go into a lot more detail, explaining what LCA is, the background, how designers can integrate this tool in their real-life project, and how NZGBC Green Star is a driver for building LCA. So without further ado, hello, Dave and Brian, can you hear us?
Yeah, we can hear you fine.
Yes, thanks for having us, Lena.
Excellent. Welcome, welcome, welcome. I'll pass you over to Brian and Dave, and they will start the presentation in a few seconds.
Right, hello everybody. So this is Dave Dowdle, Principal Scientist at Brands. I've been at Brands for about 7 years now, developing the life cycle assessment technique, so it's a great pleasure to talk to you a bit more about it today. So the first questions I want to cover are what is building life cycle assessment, or building LCA, and why consider it during design. Building LCA is a technique that allows a design team to quantify, assess, and reduce environmental impacts that are likely to arise as a result of a building design and choices of materials. It works by mapping the life cycle of a building from the extraction of materials to make the construction products through to the end of life of the building. At each stage of the life cycle and for each process, it quantifies the materials and energy required, and from this, the resulting potential environmental impacts. Having built up such a picture, a design team is able to get an understanding of the magnitude of environmental impacts and where the environmental hotspots are in the life cycle of the building. Buildings by their nature can be large, complex and long-lived products, which can leave a legacy of environmental impacts for many decades. It is the long-lasting legacy and magnitude of environmental impacts that may be incurred because of decisions taken during design that make inclusion of building LCA in the design process a powerful tool. Having timely information about potential future environmental consequences arising from a design provides for the option of understanding where these environmental impacts are arising and testing alternative design options with the aim of reducing these or potentially removing them altogether. Once a building has been designed and built, it's too late, and the best we can do is tinker around the edges. The strength of the building LCA technique is that it considers the whole life cycle, so there is no risk that a perceived environmental saving in one part of the life cycle doesn't inadvertently lead to an increased environmental impact in another part of the life cycle. Similarly, it can ensure that savings in one environmental impact are not inadvertently at the expense of increases in other environmental impacts. So firstly, we have 7 environmental impacts that are currently defined in international standards, which are listed here. You can see at the top they include climate change, as well as others such as resource depletion. All of these environmental impacts are calculated in the LCA Quick tool. Secondly, if we want to consider the life cycle of a building, we need a consistent framework for doing this. A framework for describing the building life cycle is set out in international and European standards and is shown in this slide. Here you can see the life cycle divided into 5 key stages. The product stage at the top covers the materials extracted and manufactured that are used in a building. The construction process stage focuses on transport of materials from manufacturers to a construction site and the construction process itself. It also includes manufacture of materials that become waste during construction and their associated end of life. The use stage in blue is divided into 7 modules, the most important of which is the operational energy use. From a materials perspective, this stage also looks at maintenance and replacement of materials over the service life of the building. The 4th stage considers the building demolition at its end of life and any subsequent treatment of materials for recycling. And finally, at the bottom, we have what is called Module D, which focuses on potential benefits or loads to the environment that may accrue when we reuse or recycle materials from the building. For example, the benefit of recycling steel via an electric arc furnace process rather than producing steel from a blast furnace process. So if building LCA is about evaluating environmental impacts, why should this be a consideration? Well, for projects going for Green Star, there is the Material Lifecycle Impacts Innovation Challenge, which can provide up to 6 unweighted points, which may be attractive. Brian is going to talk more about this later in the webinar. For me, I'd like to provide an overview of one of the most pressing environmental concerns that we face today, which is climate change. It's important that we all understand why almost every country has pledged to drastically cut its greenhouse gas emissions, and to also realise that we all have a part to play, both professionally and personally. I want to start with the Intergovernmental Panel on Climate Change, or IPCC, which was established by the United Nations Environment Programme and World Meteorological Organization back in 1988. Its task is to evaluate climate change science being undertaken around the world. The IPCC synthesizes the findings of this science into major assessment reports, the most recent of which was published in 2014, and from which these graphs have been taken. As I hope you can see, the top graph on the right shows increasing concentrations of 3 greenhouse gases from 1850, carbon dioxide in green, methane in orange, and nitrous oxide in red. And the bottom right graph shows the huge increase in fossil fuel combustion in dark grey since the middle of the last century. Globally, we now emit almost 40 billion tonnes of carbon dioxide equivalent greenhouse gases a year. This is resulting in increased global temperatures displayed in the graph on the top left and rising sea levels shown in the graph on the bottom left. A summary for policymakers published by the IPCC in 2014 makes some pretty sobering statements, a few of which I'd like to read. Human influence on the climate system is clear, and recent anthropogenic emissions of greenhouse gases are the highest in history. Recent climate changes have had widespread impacts on human and natural systems. Warming of the climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia. The atmosphere and ocean have warmed, the amounts of snow and ice have diminished, and sea level has risen. Anthropogenic greenhouse gas emissions have increased since the pre-industrial era, driven largely by economic and population growth, and are now higher than ever. This has led to atmospheric concentrations of carbon dioxide, methane, and nitrous oxide that are unprecedented in at least the last 800,000 years. Their effects, together with those of other anthropogenic drivers, have been detected throughout the climate system and are extremely likely to have been the dominant cause of the observed warming since the mid-20th century. It's worth noting here that the use of the term extremely likely by the IPCC is defined with a certainty of 95 to 100%. So in response, most world leaders signed the Paris Agreement in 2016, including the then Prime Minister of New Zealand, John Key. This committed New Zealand to reduce its emissions by 30% by 2030 compared to a 2005 baseline. The purpose of the Paris Agreement is to keep global warming to less than 2 degrees centigrade and ideally less than 1.5 degrees centigrade. So even if we are able to achieve the ambitions of the Paris Agreement, we will already be accepting a level of global climate change over an accelerated period that is unprecedented in modern human history. Currently, greenhouse gas emissions globally continue to rise. Also, the United States, one of the largest emitters of greenhouse gases, pulled out of the Paris Agreement soon after the inauguration of Donald Trump as president. In its emissions gap report published in 2017, the United Nations Environment Programme called for an urgent need to accelerate activities in the short term and called for greater ambition by signatory countries in the longer term. To put this in context, if we want to keep warming to less than 2 degrees centigrade, we cannot afford to emit any more than 800 gigatons of carbon dioxide equivalent emissions in total. So at a current rate of almost 40 gigatons of emissions a year globally, we have roughly 20 years left before we will start to exceed the budget we need to keep within to have a reasonable chance of keeping warming to less than 2 degrees centigrade. Now, if we look at the more aspirational target in the Paris, which is to keep a global temperature rise to within 1.5 degrees C warming, the corresponding total emissions budget is 200 gigatons, meaning we have about 5 years left at our current rate of emissions. With global greenhouse gas emissions continuing to rise, there is a view amongst some authors that it is already too late to achieve the more aspirational objective of keeping warming to less than 1.5 degrees centigrade. This diagram shows a breakdown of where emissions occur across the New Zealand economy, as reported by the Ministry for Environment. Straight away, you will notice the absence of the built environment. The reality is that the built environment is spread across all these sectors to a larger or lesser extent. Materials are manufactured by industry and transported. These manufacturing processes are powered by energy and they generate waste. Similarly, our activities within our buildings use energy and generate wastes, and some products we use in our buildings come from the agricultural sector. So if we include the contribution of the materials used to construct our buildings and the energy required to power them, a recent report by ThinkStep estimates that the contribution of the built environment to New Zealand's emissions is about 20%. So the built environment makes a significant contribution to New Zealand's greenhouse gas emissions and therefore has an important role to play in driving those emissions down. In New Zealand, currently, as with many other countries, our greenhouse gas emissions have been rising. A zero carbon bill is being prepared this year with the aim of establishing a Zero Carbon Act in 2019, which will seek to put us on a course towards a net zero carbon economy. Net zero carbon means that emissions of greenhouse gases are at a level that can be absorbed by natural carbon sinks on the planet, such as soils. Already this year, an interim climate change committee is looking at the feasibility of shifting our grid electricity to 100% renewables. We know from the New Zealand Household Energy End Use Project, or HEAP study, that 68% of energy use in residential buildings is from electricity. We also know from the New Zealand Building Energy End Use study that 85% of energy use in commercial buildings is electricity. Therefore, 100% renewables supplying grid electricity will dramatically reduce the greenhouse gas emissions arising from our built environment. However, we must also be cognizant of the greenhouse gas emissions that arise from materials choices in our new buildings. Brands calculated the greenhouse gas emissions of 10 New Zealand office buildings and simulated their operational energy use based on an Auckland, Wellington and Christchurch climate. The buildings represent a range of floor areas from 1,500 square metres to over 9,000 square metres. Energy use was calculated based on a recent grid mix applied over the life of the building. The results are summarised in the graph that you can see in this slide. From this analysis, you can see that the manufacture of materials, shown in yellow, together with transport to the construction site and installation, which is in red, provides a lifetime greenhouse gas contribution of about 20%. In other words, from this analysis, 1/5 of the lifetime greenhouse gas emissions of these modelled office buildings occurred before the buildings were even occupied. What we also know is that this 20% figure is an underestimate for 3 reasons. Firstly, we only modelled structure and enclosure materials in office buildings. So materials that go into services, internal wall, floor and ceiling linings, for example, are excluded. Secondly, if the renewables contribution supplying grid electricity is increased, the contribution made by energy use in buildings, which is the large blue segment in this picture, will reduce. And thirdly, the energy use intensity of our modelled buildings is around 113 kilowatt hours per square metre, which can be considered high in comparison with office buildings being designed and built now. The net effect of these factors is that the embodied greenhouse gas emissions are underreported and in reality will be significantly higher than 20%. So choice of materials made during the design process is as important as designing the building to be energy efficient. To help design teams get a better understanding of the potential climate change impacts and other environmental impacts of their buildings during design, Brands developed LCA Quick, a free Excel tool that can be downloaded from the Brands website. I'm now going to hand over to Brian, who will tell you more about the LCA Quick tool.
Thank you, Dave. So this part of the presentation is now about building LCA made quick through the use of our Building LCA tool. One of the main drivers for doing a Building LCA is New Zealand Green Building Council's Material Lifecycle Impact Innovation Challenge. This challenge is worth up to 6 unweighted innovation points, a significant number when you consider a 6-star building requires 75 points and above. The innovation challenge points are calculated based on the percentage of environmental reduction compared to a reference building. This is across all of the 7 environmental indicators calculated in LCA Quick. One of the requirements of this is that no one impact can increase by more than 10%. The calculation inputs required to do an LCA on a building are material quantities, operational energy, and water use. There are 2 types of reference buildings available under the Innovation Challenge to compare your design against. Firstly, an actual reference case, which is a comparison of your building design versus a real building. If this is not available, you can produce a reference building based on standard practice reference case or business as usual. Building LCA made quick. At Brands, one of the key things that we wanted to do was to make building LCA easier for building designers. LCA is a quantitative assessment method of calculating a building's environmental impact. As such, it has traditionally been data intensive and time consuming. However, Brands research has been focusing on making LCA possible and easier for people who are not LCA practitioners. Dave and I have been doing this by developing the underlying data for material and processes and embedding this in the free LCA tool called LCA Quick. All this has been done to put environmental building design back into the hands of building design specialists. What we're seeing here on the screen is an excerpt from our website, www.brands.co.nz/building LCA, or you can follow the link on this page. What you'll see here is we've developed the New Zealand Whole Building Whole of Life framework, which you can navigate on our website by clicking the 4 buttons: information, reference buildings, data, and indicators. At this level, it provides background information about what we've done. There is also, from this website, you can download LCA Quick Office, our free LCA building calculation tool. LCA Quick has been designed to link in and be compatible with BIM modeling. That's using a BIM tool such as Revit to calculate material quantities through the building schedules. It also has inputs so that you can take the energy modeling results and calculate the environmental impact of the operational energy use. At Brands, to support this, we've also created YouTube training tutorial videos, which are available by following this link. To complete the process, we've also produced an LCA report template. This report template contains all the background information required to complete a LCA compliant with international LCA standards. What we've done in the report template is pre-populate many of the LCA specific assumptions, leaving building designers, enabling building designers to enter the information about the building design that they know and focus on that. On our building LCA website, under the information section, we have two key reports. SR 349 report provides an overview of the whole building, whole of life framework and the LCA quick assessment research that Brands has completed to date. It covers the essential details about what LCA is, the building life cycle stage, the environmental impact indicators calculated, LCA quick, our focus on early design and base build, e.g. the thermal envelope and building structure. The second report, SR 350, documents the development of the Brands whole of building, whole of life reference office buildings. For building designers looking to use LCA quick in the whole building, whole of life methodology for their building projects, there are three main sections of interest in this SR 350 report. Section 4 contains information all about the main materials used in office buildings. You can use this information to inform the development of a New Zealand Green Building Council standard practice reference case building to compare your building design LCA against. Section 5 of the report contains information about the BIM and energy simulation processes. It tells you what to model and how detailed to model it so that you can produce results you trust. Appendix D contains information about what are the different processes and inputs that have been included in the life cycle of the LCA Quick material library. One of the first buildings that we've been doing is the McKee Fell building here in Wellington. This is one of the first buildings in New Zealand to go through the New Zealand Green Building Council Innovation Challenge. This was a refurbishment project, and it was looking at the environmental benefit of renovating to reuse the building's existing structure rather than a complete demolition and new build. This graph, taken directly from LCA Quick, shows the percentage difference between the building design compared to one of our Brands whole building, whole of life reference buildings. These results are preliminary, but as you can see, we're showing very good environmental savings. What you're looking at in terms for global warming is showing 106% environmental reduction of this building design compared to one of the reference buildings. This is an application of the Green Star Innovation methodology, and it's showing a potential of 5 out of 5 points being awarded. If we look at some of the other results, this graph, again from LCA Quick, is showing the building design compared to a reference building for global warming and across all the different life cycle impact stages. What we can see here is that B6, the blue bar, B6, the operational energy, is the largest environmental impact stage in the building. This is followed by A1 to A3, the yellow bar, which is the embodied material impact. If we look at if we look further at the environmental impact of the embodied energy stage, in LCA Quick, we can see what are the materials that go towards creating that impact. In another graph on LCA Quick, which I'll show you in a demonstration of the tool, it lists the top 10 building materials that contribute to that A1 to A3 impact. Again, you can see that reinforced concrete 35 MPa is one of the largest materials contributing to that overall embodied impact. Using LCA Quick, we can expand that further, asking the question of, in our BIM model, which of the BIM objects is using that reinforced concrete and what is their environmental impact? The reason we're doing this kind of analysis is that it enables us to investigate potential environmental hotspots in the building so that we can go back to the BIM model and look at replacing or minimizing the impact of that material. In LCA Quick, there is an emphasis on early design and integrating life cycle environmental assessment into the design decisions that you need to make early and then those that are cost prohibitive to change later. This is specifically focused on the materials in the building's thermal envelope and the primary or main building structure, as well as operational energy and water use. In terms of workflows with LCA Quick, the first step you need to do is to add the LCA Quick material metadata to a BIM model. This information is available in LCA Quick, and I'll show you where that is shortly. The second stage of the workflow is to use the BIM model to generate material quantities using built-in schedules and save these as a CSV file format. Thirdly, in LCA Quick, you need to enter in building design information. Fourth, you copy and paste the material quantities into the corresponding LCA Quick material sheets. These are the quantities calculated from your BIM model. Then we need to copy and paste the building design energy use into LCA Quick. Then we need to go and check the model for errors. Lastly, we can analyze results and iteratively explore design solutions and alternatives. The BIM modeling process for LCA Quick. This requires a BIM model that is constructed to around about an LOD of 200 and 300 for objects, depending on the object type. The good news is that in preliminary design or developed design, this is compliant with modeling processes that many designers already do. The process of adding LCA Quick material metadata to the BIM model is relatively straightforward. This is best done by going into the assembly build-up of that BIM object and adding in the material, LCA Quick's material description code under the material description dialog box. This is an example of that process in Revit. After that, we need to add in some information about the use of the material in terms of the paint, the maintenance, the washing, etc. At Brands, we've produced a Brands template in Revit with these material schedules and parameters already created. These can be copy and pasted into your existing BIM modeling processes. Now for an LCA Quick demonstration. go. This is LCA Quick, as you can download it from our brand's website. I'm currently working in version 3. LCA Quick is structured with a bunch of different Excel spreadsheet tabs along the bottom. The first one you're looking at is the Introduction and Architecture tool, or sheet. This sheet gives an explanation about what LCA Quick Office is, what building lifecycle assessment is, the potential environmental impacts calculated, and etc. To the left, or to the right here, sorry, you can, this tells you what the different sheets that are available are, what they can do, and how they interact together. The sheets that are shaded in green represent the sheets that require or that analyze building lifecycle assessment results. The first sheet is the summary analysis sheet. This sheet also contains the building information panel, where you enter in information about the design of the building. The cells that are colored in a light yellow are cells that require a direct input. Gross floor area, net lettable area, and the number of stories are 3 of the critical components. There are also drop-down menus that you use and select. For example, we're looking here at selecting the location. Location is important because we have built in different transport scenarios based on these 3 locations. The second analysis sheet is the Material Analysis tab. In this tab, you'll be able to analyze the results of the environmental impact of different materials. Thirdly, you can see this is the Energy and Operational Water Use tab. This is where you can analyze the results of the environmental impact of the energy use of the building as calculated or as simulated, and also the operational water use. Down the bottom here is the operational water use selection panel. This is where you enter in information about the water use of the building. These blue tabs, if you navigate across the bottom, are tabs that assist you with entering in information into LCA Quick to do the assessment. Before, I talked about the metadata entry required in a BIM model. In LCA Quick, we have a material library which has been built into the tool. You can see here that it has the product material code and a name. This product material code is what needs to be entered into your BIM material library in order for LCA Quick to recognize this material and do the calculations. We have a similar type of format for CBI codes and building element codes. There is also a tab all about the different levels of development and with some simple workarounds and unit converters for some more difficult to model materials. These sheets, 1C input, these are the inputs required for your material quantities from your BIM model. There's a sheet for paint, washing, general material quantities, and specifically one for windows, because windows are kind of difficult, and also energy use. Finally, these yellow sheets are our building export results. This is when, if you want to save the results of the life cycle assessment of one building design versus another, you can copy and paste these results across and paste them into the building data input sheet. I'm going to show you how to input information now. Here, I am just selecting the location and changing it to Wellington. When you make changes in LCA Quick with the drop-down menus or with pasting results, this automatically triggers the workbook to calculate. At the moment, I don't have any results in here, so I need to do that. You can navigate to the different sheets by going across to the bottom using the tabs, or you can use this selection and navigational panel. These buttons will take, if you press them, will take you directly to that sheet. Here, I am copying and pasting in results from the BIM model schedules, which I've pre-saved in an Excel workbook and put for the paint, and pasting them in to LCA Quick. This automatically triggers LCA Quick to calculate the results. Critically, if you scroll across, you can see that the formulas have been automatically calculated. This is a really good check process to ensure that the materials you enter are being recognized by LCA Quick and you haven't made errors with the input data codes. I'm now entering in the information about washing maintenance. On each sheet, there is at the top information about entering in the material quantities and energy use. Again, we also have YouTube instructional videos which will take you through this process in much more detail. Lastly, I have to copy in the energy modeling results. LCA Quick is now calculating. I'm going to go back to the summary analysis sheet and press calculate one more time. As you can see, information has been displayed on these graphs. Graph A was the graph that I showed earlier in our presentation, that's showing the percentage reduction of the building design compared to a reference building. In these example results, we're seeing a 70% reduction in our building design's global warming impact compared to a reference building. The reference building was automatically selected based on the building information that we had pre-entered in the building information panel. That critically, that includes location, building activity, gross floor area, net lettable area, number of stories, and also a description of the building's main structural system and main structural material. This summary analysis sheet shows the building's environmental impact across all of the 7 indicators at a whole building level. Table B is an application of the Green Star methodology for the Innovation Challenge. This is the information that is being graphed in Graph A. Down the bottom in Graph C is a copy of the graph I showed earlier in LCA Quick. What we're seeing here is global warming expressed in results of per area of net lettable area over 60 years of the building. The building design is being compared to the reference building, and you can see the different bars represent the different life cycle stages of the building. Again, you can see that operational energy is by far the largest life cycle stage impact. To analyze what is causing that result, we can navigate to the energy and H2O analysis sheet. On this sheet, we have in Graph H showing the potential environmental impact of our building design versus the reference building for different energy sources. In this case, total gas versus total grid electricity over a 60-year lifespan. Graph I is showing the same breakdown by energy use source, but looking at it from kilowatt hours per area of gross floor area per year. This is common for an EUI, or energy use intensity. Graph I2 is showing the same results of kilowatt hours per gross floor area per year, but broken down into the different energy end uses. Down the bottom, our operational water use has also been calculated. This information has been calculated by applying a benchmark figure, which we have embedded in LCA Quick based on the location of the office building. This information came from Dr. Lee Bint's PhD thesis, looking at the water performance benchmarks for New Zealand. If we go back to the summary analysis sheet and we start looking at the impact of building materials in that A1 to A3 life cycle stage, we can navigate to the material analysis tab. This is where we can see which of the building materials are contributing the most environmental impact of the building, and we can also find from the graphed in the different tables which of the BIM objects are contributing that information or contributing that impact. Lastly, I just want to point out one check feature. Before we talked about the possibility of making errors in entering in the building information metadata. On sheet material codes, we've built in a little check process where, in this case, if there has been an error in the code, it will highlight that code has not been found, or that material has not been found in LCA Quick, and a recode is required. I think we're going to leave it for that there as a quick overview of what LCA Quick can do and how it can be used to lower the environmental impact of your building design. Thank you.
Thank you, Brian.
Thank you, Lena.
Yes, will we be able to keep you for a few more moments to answer a few questions?
Yes, you can. Sorry that went a little bit longer.
Oh no, that's all good. That's all good. We've still got everyone in the room, hopefully. Perfect. So I'll just mention to everyone, now's your chance to get your question in for Brian and Dave. That was a great presentation. Thank you, guys. I'm not sure about you, but I'll definitely jump onto that YouTube training video. We already have a couple of questions in the room, so I'll just start reading them out. And we'll go through them one by one. If the question is too long, we might skip it, but we will send any answers via email as well. So you do get a chance to get an answer from us. So first question, thanks Alron for putting through a couple of comments and questions. I'll just read out your question. Why is the operational energy stage the highest global warming impact if the electricity is largely renewable? Brian or Dave, are you able to answer that?
Yeah, sure. So what we do is we analyze a breakdown of the various fuels that contribute to grid electricity, and we've worked up a 3-year weighted average based on I think it was 2012 to 2014 figures. So those figures come from MB, So at the moment, I think we're looking at around 84–85% renewables supplying the grid, and the grid average that we're currently using is probably a little bit less than that. But ultimately, yes, as we go forward and we have increasing a proportion of renewables supplying the grid, we would expect to see the grid average impacts coming down. So really, the impacts that we're calculating at the moment are a reflection primarily of the small amount of fossil fuels supplying our grid. But it is also important to understand that even renewables will have impacts. There are significant embodied impacts, associated, for example, with wind and photovoltaics, and geothermal power can also have fugitive emissions of methane.
Okay, great. Alvin, another question. Why compare to a reference building relative target rather than an absolute target, since we know CO2 emissions need to get to an absolute level?
Yeah, it's a really good question. So, I mean, at the moment, that relative approach is used in a number of countries. And of course, the problem with it is that you're comparing to a baseline, which itself is probably not very good. And the person asking the question has actually hit the nail on the head. What we really need is an absolute target. So actually, we have a research project that we've kicked off about 3 months ago now, which is going to take about a year for the work to be completed. But the aim of that research project is to develop an absolute target. So yeah, watch this space on that one. But we are working on actually trying to develop an absolute target for design purposes.
Okay, great, thank you. And here a question from Nigel Murray. What office time per GFA a square meter do you estimate you would take to estimate a building?
So I'm interpreting this as a question of how long would it take me to do or use LCA Quick on a building design. And to be honest with the audience, I don't know yet. We're working with design practitioners at the moment, and we're integrating LCA Quick in the design process, and we'll be going right through from concept preliminary design through developed design, detailed design, and possibly even construction. And so we'll get a much better indication of the time constraints from there. Me personally, being familiar with the tool, it takes me to add LCA Quick metadata to a BIM model. That's probably a morning's worth of work. The energy modeling, you would get that information from your mechanical engineer or through your Green Star process or through your building consent. So that should be, well, there's no more additional work required to do that. What we've done is we've tried to integrate it as best we can into existing workplace processes and practices, but we do acknowledge that this is a new type of analysis for the built environment and for building designers. And so with that, there will be some learning times. That's at this stage, it's worth noting that we also have a LinkedIn page, and we'll send the link around with that, where questions can be posted, and myself and Dave monitor that page and we answer them. And if you have any questions or are interested in using LCA Quick on any of your projects, please don't hesitate to contact either Dave or myself, and we can assist you with that.
Okay, perfect. We'll make sure to put that that link in our email tomorrow. And I'm not sure if you can answer how many downloads of LCA Quick you've had so far.
I can't answer definitively from our website. I don't have the analytics. But what I can say is that we've used LCA Quick on 2 projects which we've completed so far, and we've got it in the pipeline to use it on probably another 3 to 4. LCA Quick's also been used in the development of tender proposals for looking at different structural design options, both looking for designing, you know, carbon neutral or carbon zero buildings, and also other projects and the like. So what you have to realize is this is very new, and probably about 3 years ago, it wasn't possible to use or do LCA on buildings apart from going through LCA specific consultants. So we're really proud of the uptake that we've had so far. Again, if you're interested, please don't hesitate to contact us and we'll help you through the process.
Cool. Okay. Well, thanks for the questions, Nigel. Here, a quick one from Simone Bubb. Is there a possibility to do the life cycle assessment without BIM?
Yes, there is. So critically, all we're using BIM for is to calculate material quantities in volumetric units. So you could calculate or have that information calculated from a quantity surveyor, or you could do it by hand with a scale ruler and a calculator. I've done that myself as well. We also have a version of LCA Quick that we're currently working on, which is a square meter rates version, which would take the results from our reference buildings for the different constructions and express their impacts or their environmental impacts per square meter of that construction system, so that as building designers, you would be only need to select the construction system that you'd like to use and enter in the area that your building design has for that specific system.
Okay, cool. Thank you. I'm going to run through we've got another 2-3 questions here, and then we'll have to end the questions because we're running out of time. One from Caroline Cox is, I'm interested in your thoughts on how you would compare the benefits of comparing with a base build, making something less bad versus aiming for a positive impact like zero carbon, zero water, etc.
I mean, I would say on that, we would love to have some example buildings that are aspirational and world leading in terms of their environmental performance. So far, with the reference buildings we've developed, we haven't been able to obtain information on those sorts of buildings. But absolutely, I mean, at the moment, we're very aware of the fact that we have 10 reference office buildings that have been modelled in 3 climate zones. It's a small sample size, and the buildings themselves are not particularly aspirational. If anybody out there has more aspirational buildings that they're prepared to let us have the information for, we basically need the consent documentation. We would love to add to our library and have some really interesting buildings out there that are pushing boundaries, and that obviously gives a more aspirational target for people to aim for.
Cool. Yes, absolutely. And then the last ones are there any plans to develop residential versions or educational versions, or will the ref buildings other than office be added?
Yeah, in fact, we're actually in the process of developing a residential version of LCA Quick. So we've put a lot of work over the last few months, or Brian in particular, on developing a set of residential buildings. We need to expand the range of materials that we have in the library and the associated environmental impacts. That's some work that we need to do over the next few months, but we're aiming to have a residential version finished and ready by the end of the year. No plans at the moment for an educational version, although that's a very interesting idea. And again, I suppose if we can get some school reference buildings developed, then it shouldn't be too difficult to create something that could be potentially used for school applications as well.
Excellent. Well, thank you very much. Thank you all for your questions, and thank you so much, Brian and Dave. It's been great.